All right. So once again, guys, no. So very good day, everyone. Good day po, no, and welcome to the session, guys. Welcome. So for today's lecture, guys, no, so we'll be continuing, no, the module 2, no, of the feedback and control systems, okay, which is the module 2, which is the modeling, no, of dynamic systems. Okay, so we started with part 1 already, no? So wherein we modeled, no, various dynamic systems. So that includes electrical circuits, operational amplifiers, and translational systems. Okay, we also started, no, the introduction to the state space analysis. Okay, so now we'll be continuing with the session. Okay, all right. So the first topic, no, natin ngayon, okay? So we're already done with the conversion, guys, no, ng state from differential equation to state model. Okay? And then the state model to differential equation, you just need to figure out, okay, how to reverse the controllable canonical form. Okay? So I will leave it to you guys, no, for you to figure it out kung paano siya ginagawa. No, it's just ano, no, it's just working it backwards. Okay? So anyways, no, so we'll be having this having that an example again, pero in the form of transfer function na. So you'll understand it better later into the session. Okay. So anyway, guys, so let us first study yung first topic natin, which is another dynamic system, right? Which is the electrical network. Okay? So ang gagawin natin dito, guys, is we're going to convert, okay, the given electrical network into state model. Okay? So we're going to convert the given electrical network, no, to the corresponding state model. All right. All right. So here, no, our example, no, so this is an example for a basic, no, series RLC circuit. So yeah, dito natin pa-practicein, no, how are we going to do this. Okay. So for the conversion of electrical network to state model, no, so of course, no, we have what we call as our state variables. So meron tayong mga state variables. Okay. Wait lang. So we have the state variables. So the state variables, guys, no, fixed na po ito, no? For electrical network, the state variable is always the IL, the inductor current, and VC, the capacitor voltage. So bibilangan nyo lang, guys, no, kung ilan sila. So in this particular problem in the circuit, we have one inductor and one capacitor. So therefore, okay, therefore, yung state variables natin is nothing but, okay, we have the VC, okay, or unahin natin IL. So we have the I sub L, okay, and BC. Okay? So, for example, no, so mamaya yung problem natin, dalawa yung inductor natin dun. So, that will be IL1 and IL2. Okay? But in this case, the state variables is IL and VC kasi tag-isa lang naman siya. Okay. So, as you can see here, guys, no, so it's indicated in the problem that the output voltage is actually the voltage across the capacitor. So, tatandaan nyo yun, guys, no? So, bali yung output voltage natin would be the, guys, VO natin is actually the voltage across the capacitor. So, kasi later on, that is one part, no, of what we're gonna use to form the equation. Okay, also, so we have the current in here in the circuit, and since this is series circuit, guys, so the current all throughout the circuit would be the same, correct? So in other words, guys, no, the current here, okay, yung current po dito, actually, the current in the inductor, this is IL. So this would be the current for the whole circuit. Okay? So IL. So we can write this as IL actually. And then we have V in here as our input voltage. All right? Okay. So now, guys, no, we can do, okay, we can use the KVL, right? We can form or we can use the Kirchhoff's voltage law. So by KVL, so we can write the KVL, guys. So by KVL, Kirchhoff's voltage law. So we have V in, okay, this we have V in, which is the input voltage, minus, okay, IR. So IL R. And because, right, di ba? Kasi we learned that the current all throughout the circuit is the IL. Okay, and then the voltage across the inductor is nothing but LDI over dt. So this is LDI upon dt. Okay. Yan. And then we have minus the voltage across the capacitor minus VC. Okay, and then this is equal to 0. This is equal to 0. So remember guys, no, kung nare-recall nyo pa in creating a state model, so we need to have the state variables. So definitely, no, we have already the state variables, I, L, and B, C. So no problem with that. But also, we also need to get the derivatives of the state variable. As you can see here guys, no? So ang state variable mo is IL. We already have here, no, the derivative ng current. And the current guys, remember, di ba? The current here, since this is series, so this is nothing but the current also in the inductor. So this is I sub L also. So kailangan natin nung I sub L basically. Okay? So to do that, just transpose it on the other side. Gets po? This whole thing, transpose natin sa kabilang side. So that would be, yan. Tapos unahin ko lang siya isulat. So that we'll have, bali ang mangyayari guys, we have L DIL over dt. Okay? So this is equal to, okay, no? So we have V in minus I sub LR, okay, minus VC, right? So we transpose it and then we write it first. But what we need is only DIL over dt because again, we need the derivative of the state variable. So this is, ano po? This is DIL upon dt. Okay, and this is equal guys ha. Unahin ko lang isulat yung IL, no? So we have bali negative R, okay, up on L, I sub L. Okay, and then I have here minus 1 over L for the VC. Okay, and then plus I have the V in. I have the V in. Okay, so that is our first equation. That is our first equation, guys. So we can write it as an equation 1. Yeah, so this is the equation 1. Okay. So okay na, 'di ba? So we already have the state variable IL and VC. Okay, we also have the derivative of IL. Okay, so the derivative of the first state variable, okay na. So where do we get now the derivative of the second state variable? So saan natin kukunin yung VC? Okay. So remember the equation sa capacitor, okay, the current in the capacitor is actually equal sa C dV over dt. Correct? Tama ba guys? So tama, no? So kung nare-recall natin, so let me just resize this guys so that so we can write some more. So just resize this for a bit and medyo resize na natin ng konti guys. Okay. Alright. So now guys, so kung nare-recall nyo, no? Yan, tama ba? That the also, lagyan natin also, and also, yan, alam natin guys that the current in the capacitor is given as C dV C over dt, where the derivative here is the derivative of the voltage, okay, of the capacitor. Now, since this is series circuit, sabi nga natin, this is nothing but IL, right? Yan, IL din yan kasi the current that flows actually inside the capacitor, so yung nagpo-flow sa capacitor, okay, since series to, this is also I sub L. Okay? So in other words, no, if you want to get, okay, if you want to get the dVC over dt only, so dVC, okay, upon dt, okay, so this is nothing but, ano guys, 1 upon C ng I sub L. 1 upon C ng I sub L. And this is our equation 2. So this is our equation 2. And I've said before, kanina, na this is also important because actually this is equation 3. And we will see it later no, kung saan siya gagamitin. So now guys, no, so ito na yung mga computations natin. Nilagay ko lang sa gilid guys because this is where we're going to place our state model. So sa state model guys, no, kung nare-recall nyo, the state equation first, we need to get the, or we need to write the derivatives of the state variables. So sabi ko nga, pag electrical network guys, fixed na yung state variables natin. So that is always IL. So just write IL here and VC dito. Pero since this is the first one, dapat may tuldok sa taas kasi this is the derivative. Okay? And then equal po siya. This is the state matrix. Okay? And then for the state matrix, no, naka-multiply na sa kanya again yung ating state variables, which is IL and VC. Okay, plus we have the input matrix. Okay, we have the input matrix and the input itself. So the input itself is nothing but V in, right? The input itself is nothing but V in. Okay, guys. So now, let us write first. Okay? So sabi ko nga, no, we can put some markers here so that will not be confused. Okay? So we just put markers here. But take note, guys, that these markers, wala talaga yun, no? Hindi sila part ng answer natin. Lalagay lang natin para hindi tayo malilito. So this is IL and this is VC. Okay. So what is IL dot? So we're gonna use the equation 1, right? So IL dot is nothing but the derivative of the inductor current. So kita natin dito, no, yung nakatapat sa IL, tinan yung equation 1. Look at your equation 1, guys. Ano ang nakatapat sa IL? Isn't it, ang nakatapat sa IL is negative R over L. Negative R upon L. Now, ano naman nakatapat sa VC, guys? So this is negative 1 upon L. Okay? Now, guys, sa V in, equation 1, is there a V in here? Yes. What's the value? What's the coefficient? 1. The coefficient is 1. No, no, it's not 1. Sorry, no? So, let me correct this one. And my apologies, guys. It's not supposed to be 1. Yan, kasi diba, we divided everything by 1 over L. So, this is definitely 1 over L as well. No? So, yeah. So, this would be, ano guys, 1 over L also. 1 over L also. Okay? So, nagigets po? Nakuha? Yes, yes. So, what we did is we divide everything by L, no? So, it just so happen na hindi siya naisulat, no, yung over L. Anyway, not an issue. All right. No, so next natin is, okay na, di ba, yung first equation. Now, the second equation. Where's the second equation? Equation 2. So, the derivative of the capacitor voltage is nothing but 1 over C ng IL. So, you just write 1 over C here po. Okay? I'll just write 1 upon C dito. Okay? Now, is there a VC component there? Nothing. So, this is 0. Okay, is there an V in component there? Nothing. So this is 0 as well. And therefore, no, ito guys yung ating state equation. So this is nothing but our state equation. So nakuha guys, nagets po? Yes, yes sir. Or right. All right. Okay? Sige. Now guys, okay no? So kulang pa yan, 'di ba? We need to have the the output equation naman. Okay? So we need to have the output equation naman. So what will be the output equation? So be careful no in writing the output. The output is VO. Okay? The output is VO. So ilalagay natin dun sa state matrix natin, or sorry, in the output actually. So this is supposed to be V sub O. Okay? So 'di ba usually Y nilalagay natin dito or C depende sa example. But in this case, the output is V in, sorry, the V out. So we put VO. Okay? And then we just need to write the state variables natin, which is IL and VC also. Okay, and then we have the feed forward matrix, and then we have the V in. We have the V in. Okay. All right. Now, guys, no, let us write. Let us write. So, we will use the equation 3. Look at the equation 3. What is VO, guys? This is VC. So, meaning to say, in the IL equation, this is 0. So, we put 0 here in the IL part. Sir, what do you mean by IL part? Di ba may markers tayo dyan? So, yung markers dun sa taas is the same with this one. Ito rin yung marker dyan. IL and VC also. Okay, so IL 0 siya. And the value for the VC is 1. Okay? 1, right? VC is 1. Okay. And then there's no V in, no, in the V out. So we cannot see any V in there. So this is definitely 0. Okay? And yan, this is our state model. Okay? This is our state model. Now, no, so if you can erase, it's much better to erase the markers so that you'll not be confused with your final answer. Will not be confused with your final answer. Okay guys, so naintindihan po yung pag-create ng state model, okay, from the electrical network. Okay, sige. So if yes, let's move on sa next example. Okay. So next example guys, yan, determine the state space representation or the state model actually yung ibig sabihin yan of the given network. Let I be the output. So in this case, yung I, as you can see there, yun yung output natin. Alright. Okay. So now guys, no? Okay. As you can see here, okay, dalawa na yung inductor natin, correct? Dalawa na yung inductor. So definitely, we have two, guys, we have two state, we have three actually, kasaming capacitor voltage. So let's say this is plus minus, okay, VC. Ayan guys. And then we have the current here of this inductor po. So this is IL1. Okay, and then of course we have the current here of this inductor, guys. So this is nothing but IL sub 2. This is IL sub 2. Okay, no? So makikita natin dun sa mesh currents, no? So if you look at if you analyze it, so definitely this will become the IL1 and definitely this will become the IL2. Okay, based do sa looping niya, right? So yeah. Okay. Anyway, so let's now solve the problem. So the way that we solve this, guys, no, actually, so solution tayo is that, of course, no, the way that we solve this is we identify the state variable first. So ano yung mga state variables natin? So just write state variables. Okay, so what are the state variables natin, guys? What are the state variables? So sabi ko nga, kung ilan yung ating energy storing component, like ilan yung inductor and capacitor here, those are the state variables. So in this case, we have IL1, IL2, and VC. So just write IL1, okay, and then we have the IL2, and then we have the VC. Okay. Sir, the order, does it matter? Uh, Okay, no? So, let me tell this to you guys, no? I haven't told this to you in our live classes. Okay? Ganito, guys. The state model, okay, the differential equation, the transfer function, they are unique models. Okay, when I say unique models, no? So, in this particular circuit, isang differential equation lang ang pwede mag-represent dyan. Also, transfer function, di ba, we have learned how to do it, how to represent this one is in transfer function. Isang transfer function lang din ang pwede mag-represent dyan. However, okay, when we're talking about the state space representation, state models, there are many possibilities. There are several possibilities of state model that can represent the same system. State space representation, state model is not unique. Okay? Hindi po siya unique. So maraming possible na answer. Kasi guys, no, if you will interchange the order, like for example, inuna mo yung VC bago yung IL1 and IL2. Okay? Or inuna mo yung IL2 before the IL1, before the BC. Okay? So, what will happen is your answer will change actually. Okay? Your answer will change actually. So, in terms ng grading, no, so I'll be specifying, no, in what order, okay, you need to arrange, no, your state variables for us to have an easy time checking your or marking your papers, no? Ayan, marking your exam papers, no? Siyempre, mahirapan din naman tayong mag-verify ng correctness ng inyong answer kung iba-iba ang inyong magiging sagot. Okay? Kung iba-iba yung magiging sagot nyo, guys, no? So, yan, no? So, yan. To answer that question, no? So, yes, no? So, the order matters. So, if you rearrange it in such a way na iba rin yung magiging answer natin. So, again, guys, no, I'll be specifying what should be the order of the state variables when you're solving the problem. At any rate, no, so let's use this order, no? IL1, IL2, and VC. Okay? Okay, sige. So the first thing that we need to do is we need to have the KVL at the loop 1. So let's say, guys, that this is the loop 1. Okay, so this is the loop 1, guys. And this is the loop 2, no? Yan. Para lang may marker tayo kung ano siya. So we have the KVL at loop 1. Okay. So by KVL, Kirchhoff's voltage law at loop 1, guys. And by KVL at loop 1. Ano, so ayusin ko yung pagkakasulat, guys. So loop 1. Okay, by KVL at loop 1, guys. Okay, no? So we have, this is V in, guys, no? So kung medyo malabo po. So this is actually V in. So, yeah. Let me just fix this one. I think it's a little bit, medyo malabo. Okay, so let's say this is V in, guys. This is V in. Okay. And the output is the current I, no? So anyway, so V in, guys, right? So we have V in, by KVL, so we have the V in. Okay. Minus, okay, the current there is IL1. So, minus IL1, okay, into 1. So, hindi ko na siya susulat, guys, because 1 ohm yung resistor. Okay, minus, okay, we have the inductor there. So, the inductor voltage is LDI over dt. But L is 1, right? So, I'm just writing DIL1 up on dt. Okay, so dito you need to be careful, no, kasi dapat ilagay nyo kung ano ang anong IL yon kasi dalaway IL natin. Okay, minus the voltage across the capacitor. Okay, is equal to 0. Is equal to 0. Okay, remember that we need to get the derivative of the state variable. So ito na yun, guys, right? Ito na po yun, right? Ito na yun. So you just need to transpose it and write it first. So this would nothing but This is nothing but, uh, this is nothing but DIL1 upon DT. Okay, this is equal guys sa ano po. Pag nilipat natin to, so this is negative IL1 guys, and then we have minus VC, and then plus Vin. Okay, so this is equation number 1. So this is equation number 1. Okay, next, we're going to perform KBL sa loop 2 naman. So by KBL at loop 2, by KBL at loop 2. So we're going to perform KBL at loop 2. So pag nag-KBL tayo sa loop 2 guys, okay? Ayan no, so start tayo doon sa voltage ng capacitor, okay lang? So we have the voltage ng capacitor. Okay, minus, dadaan tayo sa inductor, right? So if you're going to trace that, dadaan tayo sa inductor. So we have minus, okay. The voltage across the inductor is LDI over dt. So the voltage in the inductor is LDI over dt. Okay. The voltage in the inductor is LDI over dt, but L is 1. So this is nothing but, okay, DIL2 upon dt. Okay, DIL2. Kasi current natin, di ba, is IL2. Okay, guys. And then, meron tayo, dadaan siya sa resistor, guys. And yeah, the resistor, that is 1 times IL. So that is minus IL2. Okay? So, but IL2 lang kasi the resistor value is 1. So, 1 din yung value ng inductor kaya hindi na natin siya isusulat. So, this is equal to 0. Yan, kasi wala naman siyang dinaanan na V in. So, this is equal to 0. Okay? So, hindi po ito mesh analysis, no? It's just a simple KVL. So, lilipat lang natin, guys, yung DIL2 kasi yun yung kailangan natin. Remember, di ba? What we need is the derivative of the state variable. So, lilipat lang natin siya, guys. So, this is nothing but DIL2 and IL2 upon dt. Okay, this is equal guys saan? So this is equal sa, pag nilipat natin siya, this is negative. Okay, negative IL2, okay, plus VC. Negative IL2 plus VC. Okay, and this is equation number 2. So this is equation number 2. Okay. All right. So now guys, no, so what's next? Now what's next? So okay na 'di ba? May derivative na tayo ng first state variable. Okay, that is DIL1 over dt. Yan no? So meron na tayong derivative nito. We need this one kasi, 'di ba? Right, no? So this is basically your IL1 dot, correct? And we also have the derivative of the second state variable. So okay na rin 'yan because this is the IL2 dot. Okay, so okay na yung dalawa, right? So ano na lang kulang, guys? So we need the derivative ng third state variable which is the capacitor voltage. Okay. Yan. So somehow this part gets a little bit confusing for some. Okay, again, what can we do, no? To get the derivative of the state variable. Alam natin na for a capacitor, so we can write also and also we know guys no that the current in the capacitor, okay, the current in the capacitor is nothing but the derivative of the capacitor, I mean derivative of the capacitor voltage times the capacitance. So in this case, okay, in this case guys, the capacitance is 1. So we can write 1, okay, multiplied by dVc over dt. Okay. Now, yan. So, 1 po ito, no? Medyo pangit lang yung naging itsura. So, this is 1, guys. So, let me write it. Yeah. Okay. What is I? Okay. I is actually the current that enters the capacitor. Okay, guys? So, yung I na yun is the current that actually enters the capacitor. So, kung papasok sa capacitor, guys, look at this closely, no? Pag papasok sa capacitor, ito yung magiging net na positive and this is the net na negative. Gets po? Kasi 'di ba papasok yung IL1, palabas yung IL2 if you will trace it. No, no. So ite-trace mo yung loop na 'yan, 'di ba? So pag ganyan yung loop, no, palabas siya. Pataas siya, no? So palabas siya ng capacitor, yung isa ay papasok. What do you mean? Bakit papasok yung IL1? Kasi pag ano yung direction niya, right? Pag ganyan yung direction niya. pa-clockwise. So it enters the positive terminal. And the IL2, since pa-clockwise din yung direction niya, but because of its orientation, it goes in the negative terminal. So minus po yun. Okay? Yan. Nalilito yung iba dyan eh. Okay? So basically, no, so this is nothing but IL2 IL1. So this is IL1 minus IL2. Okay? So, yun yung net positive natin. Net positive natin is the one that enters the positive terminal, and the one that leaves the negative terminal, the one that enters the negative terminal is the net negative natin. So, this is nothing but, dVc upon dt. Okay? All right. So, we just flip it, guys. We can just simply flip it po. Okay? We can just simply flip it para maayos lang tignan. So that would be dVc upon dt. So this is nothing but IL1 minus IL2. Okay, guys? All right. Yan. So ito na ngayon yung equation 3 natin, guys. So this is equation 3. And that's what we need actually, no? So we just need this one also because ito na yung derivative ng third state variable mo, no? So ito yung VC dot natin. That is the VC dot, okay? All right. All right. Okay, guys. Now. Okay? What we need now is the output na lang. No? So we need the output. Okay, as you can see, no, the output here is I. So pataas yung I, guys, no? So ano pwede nating i-relate sa I? No? So by KCL dito, guys, no? So let's say this is node A. Yan. So let's say that this is node A, guys. Yan. So by KCL sa node A po. Yan, by KCL at node A. So by KCL, okay, at node A. So, by KCL at node A po. Yan, node A. So, by KCL at node A, what is the current that enters node A, guys? IL1. Anong current pang nag-enter sa A? I. Okay, current entering the node equals current leaving the node. Ano yung lumabas na current sa kanya? IL2. Correct? Diba? IL1 enters node A, I enters node A, IL2 leaves node A. So, incidentally, no? So, we want to find I because that's the output. So, yung I natin, this is nothing but IL2 or negative IL1, guys. Negative IL1 plus IL2 plus IL2. And this would be your equation number 4. Equation number 4. Okay, guys? Yes, yes. All right. So now we are done with all the equations that we need for us to be able to write the corresponding state equations, no, or state model. Okay? But siguro let me just resize this. Okay. So resize lang natin. Just erase this. Yan. Buuin ko lang, no? Naputol kasi. So, this is also, ibig sabihin nito, also, and this is the I. Okay. So, hence, no? So, now, we're going to write the corresponding state model. So, sa state model, guys, di ba, sabi nga natin, we just need to write the state variables. So, ano yung tatlong state variables natin, guys? So, we have IL1, we have IL2, and we have the VC. Kaya lang, since this is the first matrix, dapat may derivative lahat yung tatlo. Dapat naka-derivative yung tatlo, guys. Okay? So, this is equal po saan? So, we will write the state matrix. We will write the state matrix. Okay. Yan. So, we have, again, this is IL1, this is IL2, and this is VC. Okay, clear? Okay, plus, okay, the input matrix, guys. Input matrix. And this is the V in. This is the V in. Okay, no? So ano pong isusulat natin dito, guys? Okay, so let's put some markers po. Let's put the markers so that we will not be confused. So this is IL1, this is IL2, and this is the VC. Okay, first equation. Look at the first equation, guys. Look at first equation. So sa first equation, 'di ba? DIL1 over dt or yung IL1 dot, no? So this is nothing but negative ng IL1. So we put negative 1 here. Okay, so IL2 wala. So that is 0. And then for BC, this is negative 1 also. Okay, tapos sa VIN we have 1. So put 1 here. Okay, guys? Tama ba? Look at the equation 1. Negative IL1, so may negative 1 ka doon. Wala kang IL2, so that is 0. Okay, and then you have your VC also, so negative 1 sa VC. Okay, and then VIN is 1. For IL2 naman, guys, no? So we can see here sa IL2 ay 0 po ito. So wala tayong IL1 sa equation natin. But we have IL2, so that's negative 1. Okay, and then BC, positive 1. We don't have any V in, no, in the equation 2. Look at equation 2, walang V in dyan. So that is 0. Okay, now let's go back sa equation 3 naman. Sa equation 3, IL1 is positive 1. Okay, IL2 is negative 1. We don't have any VC here, so we put 0 sa VC. And then we also don't have any V in, so we put 0 sa V in. We put 0 sa V in. Okay? Right, guys? Yes? Yes, sir. Yes? Yes, sir. Okay. Sige. Now, for the output naman, okay, for the output, okay, no? So, ingat lang ha sa pagsulat. The output is what? The output is I. So, you just write I here. Okay, and this is equal sa, okay, you just write the, ano, no, the output matrix, but don't forget to write the state variables also. Yan. So, ano ba yung mga state variables natin? We have IL1, we have the IL2, and we have the VC. Okay, and then the feed forward matrix. And then we have the V in. Okay, guys. So, what is I? So, look at the equation 4, guys. Okay, negative 1 siya kay IL1. So, this is negative 1. Okay, and then kay IL2, positive 1. So, this is positive 1. Kay VC, we have 0. So, you put 0 here sa VC. Okay, and we don't have any V in sa equation 4. So, this is nothing but 0 also. Yan, no? So, yan yung sagot natin, guys. So, from this electrical network, we are able to derive or we're able to write the corresponding state model. So, yan yung state model natin, guys. Okay? So, naunawaan po. Ayan, no? So, it's just a matter of doing KVL, okay, and then KCL if needed. Okay, just use all the simple equations for the KVL and KCL. So once makuha na natin yung mga relationship na kailangan, basta remember the goal is to get the derivatives of the state variables. And how do we know ano yung mga state variables natin? State variables are nothing but the energy storing elements sa isang circuit. So in this case, lagi po siyang inductor, current, and the capacitor voltage. Okay? All right. So now guys, no, paano naman for translational system to state model? So paano naman natin sinasolve, no, if we have a translational system to state model? Okay, sige. So ngayon to solve this one, guys, okay, no? For translational system po, fix na po yung ating state variables. So ano yung state variables natin, no? So I'll tell you later, no? So I'll just write the solution first. So for the solution, guys, okay, yan. So actually, fixed na po ang state variable, no, pagka translational system. Actually, mas madali ito kaysa sa circuit. Because sa circuit, yun to analyze pa. Ito fixed na eh. Okay, ano yung state variables dito, guys? So, state variables natin dito, fixed na yan. Laging ganun, ha? So, ano yung state variables natin? So, ang state variables natin is always x1. Okay, kung dalawa, may x2. Yan. And then the v1. So, ano yung v1? V1 is the velocity. Okay? V1 is the velocity, okay, of the object. Okay? So kung dalawa yung object natin, we have x1 and x2. Okay? So we also have v1 and v2. If you still remember, no, we have solved this in class. And when we solved this, no, this particular problem, guys, this very exact problem, what we did is we included another mass here, no, because this is zero mass. But that is only the solution method. In reality, wala naman talagang mass doon. So hindi natin siya lalagyan ng state variable. Nakuha? Nagets, guys? 'Di ba? No, if you still remember, no, the solution method that we had here in our class, to understand how it works. So 'di ba, we actually put here a zero mass. So we naglagay tayo ng zero mass diyan. Okay, because 'di ba, I've told you in class that you can only apply force, no, if there's a mass. Okay? However, that zero mass is actually zero in value. So therefore, hindi mo siya assignin ng state variable. So kung may another block dyan, as in solid block talaga na may mass, then that's the time that you put x2 and v2 as another state variables. But as it stands, ito lang muna yung ating state variable. No? So we have x1 and v1. Okay, guys. So the way that we solve this one is actually manggagaling sa equations of motion. Okay? So if you remember, no, the final part, no, nung equation ng motion natin dito. So for equation of the motion, for equation, yan, equations of motion. So kung nare-recall nyo, di ba, we are able to write the equation of motion of this problem before. So I'll just directly lift this now from our lecture notes. So this is nothing but, okay, 3s squared, okay, plus 2s, okay, multiplied by x1 of s, okay, is equal sa f of s. Yan. So, nasulat na natin to, no? Ito yung na-simplify na, guys, no? And then, we're just about to get the transfer function here, right? Okay. But instead of getting the transfer function, ang gagawin natin is i-distribute natin to actually. So, this would become 3s squared, okay, x1 of s, okay, plus 2, okay, x1 of 2s, no? Sorry. So, this is 2s, x1 of s, okay, is equal sa f of s. Guys, no, kapag state equations, so the highest order here, in this case, yung highest na yung highest na power ng s dapat po ay leading niya is 1. So in other words, guys, no, this would be actually s square. Yan, s square x1 of s. Dapat maging ganun lang. So divide natin everything by 3. So this would become what? Plus 2/3. Okay, so this is 2/3 ng ano po? S, x1 of s. Okay, and this is equal sa 1/3 ng ano po? F of s. Okay? And then we're gonna get the inverse Laplace transform of this one. So, anong inverse Laplace nito, no? So, this is second derivative ng ano, guys? X1. Okay, upon dt square. Okay, plus, this is 2/3 ng ano, guys? First derivative, no? First derivative ng x1 with respect sa time. Okay? We don't have any x element here. And this is 1/3 f of t. So this is 1/3 f of t. Okay, guys. So this is now our differential equation. So this is now our differential equation. Okay? Next. Okay, no? So state variables, no? So we already have the state variables, which is x1 and v1. Actually, guys, okay, yung dx1 over dt, because sabi ko nga, guys, di ba, we need to get the derivative ng state variable. This is always your v1. Okay? Yan, this is our first equation. Sir, saan po nanggaling yan? Sa physics, guys, right? Di ba? Ang derivative, guys, ng displacement is nothing but the velocity. Now, guys, what is the dx square? D square rather. D square x1 upon dt square. So, ano po yan? So, ito ay equal, guys, saan? Equal po siya sa, yan, galing sa differential equation. So, this is negative 2/3. Okay, this is negative 2/3 ng ano po? dx1 upon dt. Okay? Yan. Plus 1/3. Plus 1/3 f of t. Plus 1/3 f of t. Yan. Saan po nanggaling yan, sir? Doon po sa differential equation. Doon sa naka-underline ng pitch. So, tinaspose lang natin yung, yan. Okay. Now, what is this one, guys? Ano po ito, no? So, this is nothing but the second derivative ng ano po? Second derivative ng displacement. So, in other words, no, this is V1 dot, right? This is the derivative of the velocity. And this one, this is the derivative of x1, no? So, this is actually V1, right? Tama? Yes. So, basically, this would be your equation 2. This would be your equation 2. Now, according sa problem, the output is x1. Yeah, no? So, for this one, no? So, usually wala namang variable na naka-assign for the output of translational system. So, maybe we can just use the y. Okay? Let's just use the letter y instead. Okay? So, for the last equation, guys, no? So, since sinabi lang kasi rito, di ba? X1 be the, yan, X1 daw be the output. Okay? So, X1 is actually the output. So, wala namang, usually kapag translational system, we don't assign any letters. Okay? I think they are using Z. So, maybe we can use Z instead, no? Yeah. So, Z na lang, no? But any letter would do, no? Well, usually Y. Pero I think Z pag mechanical pala, no? I mean, pag translational system, I think they are using the letter Z. So, at any rate, the Z is nothing but X1. Okay? Nothing but X1. Because sabi daw, di ba, the output is X1, so Z is equal sa X1. So, this is our equation 3. This is our equation number 3. Okay? So now, no, okay na, no, available na yung derivative, no, ng state variables. So I think di ko na-mention to, no, ang dx1 over dt. So this is nothing but x1 dot, right? Okay. So we can now write the, guys, we can now write the state equations or state model. So first is, po, we will write the state variables. And sabi nga natin, no, we just need to get the derivative of the first ng state variable muna. So, yan, x1 dot b1 dot equals, we have the state matrix, guys. So, we have the state matrix. And then, naka-multiply sa state matrix yung state variable. So, which is x1 and v1. So, sir, lagi pong x1 and v1 kapag translational system? Yes. Okay, plus, yan, the input. Okay. Yeah, no? So, ang input natin dito is f, right? This is f. As we can see here, no? So, f of t. So, this is f. All right. So, we just put markers here so that we're not be confused. So, this is x1 and v1. Okay, guys. So, for the first equation, x1 dot, so may value lang siya sa v1, right? So, may value lang siya sa v1. So, this is 0, 1. Okay? Do sa equation 1, there's nothing mentioned about the f there. So, this is nothing but 0. This is nothing but 0. Okay. Now, for v1 dot, so v1 dot, no? So look at the equation to v1 dot. So this is negative 2/3 v1. So 0 siya sa x1, guys. Pero negative 2/3 siya kay v1. Okay? Negative 2/3 po siya kay v1. Alright? And then dun sa f of t, there's a 1/3 there. So you put 1/3 here. Okay? Yan. So that's it, guys, no? So that is the state model of the the state equation. Kaya lang to complete the state model, we need the output. So sabi dito, the output is Z. So I'll be using Z here. So this is Z, guys. Yan. So this is nothing but, so let's have a output matrix again. And then the state variables. So in this case, we have X1 and V1. Yan. And then we have the feed forward matrix, guys. Okay. So, sir, napansin ko po, no, madalas po ba talaga zero yung feed forward matrix? Actually, yes. No, so it depends on how you set up the input. But always look at your output equation. Kung walang presence ng input doon, usually kasi nangyayari yun if the system has some sort of a feedback. Okay? Doon lang magkakaroon, guys, ng value to, no? Meaning to say, kung nag-appear din sa output mo yung input, no? But in most cases kasi hindi, no? So, mga examples natin. Okay, at any rate, no? So, guys, what is equation 3? Z is equal sa x1. So, may bilang lang siyang isa sa x1, then 0 dito sa v1 kasi wala namang v1 doon. Z is equal to x1 lang. And we also don't have any force there, so this is 0. Okay? Yan. So, basically, no, this is the state model of the translational system. So as we can say, as I've said, no? So translational system, guys, it's a lot easier, no? Para ma-figure out mo yung kanyang state model. Hindi siya kasing hirap ng circuit, no? Because sa circuit, you need to perform some circuit analysis pa. So ito, very straightforward. So the steps are, number one, identify the state variables. Number two, write the equations of motion. Number three, derive the differential equation. And then number four, set up the variables, get the derivative of state variables, and then yan, you can write the corresponding, ano guys, you can write the corresponding state model. Okay? All right. So yeah, that's it guys, no, for the translational system to state model. So moving on, no, sa next topic natin. Ayan, this one guys, no. Very very nice topic po. What's that? So this is the conversion guys, no, ng transfer function to state model. Okay? Conversion guys ng transfer function to state model. So remember, 'di ba, during the lecture ng module 1, we have discussed that we have actually, three lang, pero may fourth, right? Na basically, four mathematical models, no, of a control system. So the first one is differential equation. The second one is the transfer function. The third one is the state space, no, or the state model. And the fourth one is the impulse response. So marunong tayong mag-convert, no, ng differential equation to state model. We have learned that in the previous meeting. So that is by the use of the controllable canonical form. So now guys, we're going to study paano naman mag-convert, no, ng transfer function to state model. So I'll be teaching you several forms, no, that we can use, no, para dito. Okay. Sige. So the ECS 1 muna, no. So what will be the solution? So the ECS 1, alam ko familiar na kayo dito guys, is what we call as the CCF. No, so pwede rin gamitin yung controllable canonical form po dito. So we can also use the controllable canonical form here. So what will be the solution? Okay, solve po natin. Kaya lang, no? So, to make the controllable canonical form work, so we need to express it in a standard format. So, we have C of S upon R of S. Okay, anong standard format yan, sir? So, dapat, guys, yung leading coefficients, no? The leading coefficients, no, of the denominator and numerator should be 1. So, in this case, yung leading coefficient ng S cube, di ba S cube yung highest power sa denominator? This one, S cube. So, yung leading coefficient niya is already 1. Okay, so no problem at all. You just write it that way. Okay? So, wala nang problema. Sulat nyo lang. So, S cube. Okay, plus 9S square. So, 9S square. Okay, plus 26S. 26S plus 24. No problem at all. However, in the numerator, hindi ganun, right? Sa numerator, if you gonna look closely, sa numerator, the leading coefficient is 3. So, hindi pwede, guys. You need to factor out. So, pag factor out natin yung 3, anong maiiwan, guys? So, this is nothing but S square. And this is nothing but 10 over 3S. Okay? And then we have plus 2/3. Okay? Dapat po ganun. So, dapat yung leading coefficient natin, no? So, kung naaalala niyo yung pole zero form, you may gain. Yeah, some sort of that. Pero no need to factor out for the poles and zeros, no? So, kailangan nyo lang makuha yung gain, guys, no? Kailangan nyo lang makuha yung gain. Okay, so itong gain na to, no? Gagamitin po kasi natin siya later on. Okay, guys. So now, paano po ang gagawin? Okay, no? So using the controllable canonical form, so using CCF, no? So nare-recall nyo pa yung pagsulat ng CCF, ganun pa rin, no? How do we write the CCF sa differential equation is the same as how we write the CCF, guys, no? Sa transfer function to state model. First step, count the number of state variables. Paano malalaman yung number of state variables? It is based upon, okay, the highest power in the denominator. Because that is the order actually. Third, no? So in other words, guys, no, meron tayong 3 state variables. Okay, meron tayong tatlong state variables. So we have the x1 dot, x2 dot, and x3 dot. Okay, guys? Okay. Equal to, guys, saan? Equal to, guys, saan? So equal po ito sa, okay. Yan. So we have the state matrix actually. All right. Yan. So this is the, oops, sorry. Yan. So this is x1, x2, x3. Okay, and then we have the input matrix, guys. And this is R, right? This is R. The input is R kasi C of S upon R of S. Now guys, sa controllable canonical form, no, kung nare-recall nyo pa, di ba, we will write 0 and then 1 and the rest are zeros. Next row, shift 0, 0, 1. Now, paano po ito, no? Yung last, ano natin, yung last row po natin. So sa controllable canonical form, you will start at the end. So this is 24, pabalik. Pabalik, guys. Okay? Pabalik po. So in other words, no, this is negative 24. This is negative 24. Okay? We have negative 26 and then negative 9. Okay? So that's how you write it. Tapos, di ba, sa controllable canonical form also, yung input matrix natin ay all zeros except sa dulo. Ano yung dulo? Yung gain, 3. Ah, ganun pala, sir. Yes. So that's how you write, no? The CCF or controllable canonical form of conversion and transfer function to state model. Ah, dali lang pala, sir. Yes. Okay. All right. All right. Okay. Now guys, no, so syempre may output matrix pa rin tayo. So paano yung output matrix, sir? So yung output natin, di ba? Output matrix, output equation. So this is C. And because C yung variable natin, right? Because this is C of S upon R of S. So what is our C, guys? Okay, bagyan pa din. Yan. Ito yung pagkakaiba niya sa differential equation, no? So there's a big difference, no, between how you write differential equation and how you write the state model ng ano, guys, transfer function. Okay, by the way, no, the feed forward matrix is still 0. Okay, pagka ano, no, controllable canonical form, guys, ng ano po. Okay, ng transfer function. So this is still 0. This is still 0. Okay. Now guys, look at the numerator. Numerator tayo, guys. So the numerator, okay, read it backwards also. Okay? But take note, guys, the numerator should be positive. Ito dapat ano siya? Positive, meaning no change ng sign. So this is negative, no? Mumultiply mo by negative 1 or in other words, the denominator should have the change the sign. Should have the change the sign. By anyway, so if this is positive, guys, so pabalik, that would be 2 and then 10 and then 3. Okay, we have 2, 10, and 3. All right? Yes, yes. So that is the answer. Okay, that is how you convert, no, a transfer function to state model using the controllable canonical form. Okay. Now guys, mayroon pa ba bang form, sir? Meron pa. Okay, so I will teach you another form, guys, no, na you can use, no, to write a certain transfer function, no, to state model. Because I mentioned, guys, no, during the discussion earlier that the state model is not unique. Transfer function is unique. Differential equation is unique. Pero for a system, there can exist, no, different forms of state models. So what I will be teaching you now is what we call the observable canonical form. Okay, so we have the observable canonical and form. We have the observable canonical form. So we say observable canonical form, this is the OCF. Okay, by the ano acronym, no? So you have OCF. Okay, observable canonical form. So paano pa yung observable canonical form? Actually, if you know the CCF, you can write directly the observable canonical form. So paano yun, sir? So let's just copy the state variables. So we have x1 dot, we have the x2 dot, we have the x3 dot. Okay. So and then equal po yan. May sa answer. So we have another state matrix, guys. Okay, and then this is a state variable. So this is x1, x2, x3. Okay, and then we have the input matrix. Okay. Yan, and this is definitely R. Okay. Now guys, ang gagawin po natin is we will just transpose the state matrix of the CCF to obtain the state matrix of the OCF. So we just need to get the ano po, transpose. Paano po mag-transpose, sir? You will read it horizontally, but you will write vertically. So, di ba? 0, 1, 0. So, 0, 1, 0. And then, 0, 0, 1, 0, 0, 1. And then, negative 24, negative 26, negative 9. So, you have negative 24, negative 26, negative 9. That's it. That's it, guys. So, naintindihan, guys? Alright. Now, okay. Paano naman po yung R? No, yung input matrix. So, whatever your output matrix will now be in your input matrix. So, that's 2, 10, 3. No, so this is nothing but 2, 10, 3. 2, 10, 3. Gets? So, yung 2, 10, 3 kanina, itatayo nyo lang, 2, 10, 3. So, ngayon guys, no, for the output naman, okay, for the output ng observable canonical form, so this is C, right? Okay, ang mangyayari naman is yung sa controllable canonical form kanina, so this is x1, x2, x3, okay? So this is, again, the feed-forward matrix, guys, no, for observable canonical form is also 0. And this is R. Okay, guys, ito naman, 'di ba, yung kanina yung 003, hihiga naman siya, no? So this would become 003 naman. Okay? So that's it, guys. That's it, no? For the observable canonical form. So that's it, no, for the observable canonical form. Okay, that is for the observable canonical form. Okay? So, naintindihan, guys? Yes, yes, sir. All right. All right. Okay? Sige. Now, using the same given, no? So, the same given, okay? We will not do this anymore live, no? So, pinakita ko lang, guys, na, ano, no? I mean, nilagay ko na. Yan yung partial fraction niya. So, we can get its partial fraction and ito po yung lalabas, no? Yung 3s squared plus 10s plus 2 upon s cubed plus 9s squared plus 26s plus 24. Ito po yung result in the partial fraction. So, bakit nyo po pinartial fraction, sir? Okay, pinartial fraction natin siya because ito pwede natin it will introduce us to another form. And what form is that? That is the diagonal canonical form. Okay? So, yan. So, using diagonal canonical form and using yan, DCF naman. So, diagonal. So, we have the diagonal canonical form. Yan, or the DCF. Okay, we have the DCF. Diagonal canonical form. Okay. So, paano po yung diagonal canonical form, sir? It's just the same. Just the same. So, we have three state variables. So, x1, x2, x3. Yan. Kasi meron tayong tatlong partial fraction. I mean, tatlong elements ng partial fraction. So, we have 3. Okay? Yan. By the way, no, diagonal canonical form only works if your poles are simple poles, like s plus 4, s plus 3, s plus 2. So, it will not work if you have repeated poles. So, pag repeated poles, guys, okay, we'll be using another form. Okay? We'll be using another form. And that is yung next dito, no? Yan, ituturo ko mamaya. Okay? So, anyway, paano yan, sir? No? Paano po yan? So, by the name itself, no, diagonal canonical form, so, ang mangyayari is the poles, yung mga poles natin, okay? Yan, wait lang ha. Isin natin. And this is, okay, x1, x2, x3. Okay? And then we have here, plus, yan. So, yung matrix B naman to. Yan. So, the inputs still are, so you put R here. Okay? We put R here. Okay. Sige. So, paano to, no? So, di ba, we can see here that the poles are what, no? Sige nga, practice tayo, guys. What are the poles? So, we have the P1 to be equal sa, yan, I mean, pole 1, S equals -4. We have S equals -3. And then we have S is equal to -2. Okay? So we will write the poles at the diagonal. Kaya nga siya diagonal canonical form eh. So we have -4, then we have -3, and then we have -2. And the rest will be filled with zeros. And the rest will be filled with zeros. Okay? Yeah, that's it. That's how you write the, guys, diagonal canonical form. Again, paano siya uli, sir? So again, sa diagonal canonical form, sa diagonals, guys, you will put the poles. So we have -4, 0, 0, 0, -3, 0, and then we have 0, 0, -2. Sir, how about the order? Is it in any order? Yes. Okay? Kaya nga sabi ko guys, so it's in order. So maraming pwedeng possible na answer. Right? Yeah, no? So if I will be asking you to write it in a diagonal canonical form, maybe I'll just say na increasing rule, increasing poles or decreasing value poles, etc. Okay, guys? So I'll just provide a rule or some rule for you to follow para maging pare-pareho yung sagot natin, guys. But definitely, no, in reality, in any order yan, pwedeng mauna yung -2, pwedeng mauna yung -3. It's just the same. Doesn't matter. Okay? Now, guys. Now, paano po yung input matrix? Okay. So, I will write the output matrix as well, kasi magkasabay natin siyang, pwede kasi magkasabay gawin yun. Okay? So, again, this is the output matrix, guys. Okay? And this is the X1, this is the X2, and this is the X3. Okay? Again, still, the feed forward matrix is 0. Okay? So, the feed forward matrix is 0. Okay, guys. Ganito. Okay? This is C, right? This is the output. For diagonal canonical form, di ba ito yung mga ano natin, no? Ito yung mga residue. Residue yung tawag dyan, di ba? Ito yung mga residue or mga numerators ng iyong simple pole. Yan, ito yung mga yun, guys. Okay? Yan yung mga yun. Okay? Now, itong mga number na ito, okay, the product, okay, of the corresponding elements of the input and output matrix, pag minang-multiply mo yun, dapat yung mga yan yung lalabas. Like for example, di ba yung unang element ay 5? So, if I choose this to be 5, okay, this is 1. Nakuha, guys? Basta ang product nila ay 5. So, sir, pwedeng baliktad. 5 tsaka 1, pwede. Yes. So, even 2.5 and 2, it's okay. Like, for example, I choose this to be 2.5. Then this is 2. Okay? As long as their product is the same, is always 5. Right? So, maybe we can write this as 5. Usually, ito yung ginagawa nilang 5, ito yung ginagawa nilang 1. Okay? Now, how about the 1 here? So, pwedeng, I will make this 1/2 and this is 2. No problem. Okay? So, basta ang product nila is yung numerator ng iyong S plus 3. Okay? So, in this case, ginagawa nilang 1 to para 1 lang din yun. I mean, 1 times 1 is 1. And then we have -3. Huwag kayo ma-confuse -3 po yun. So, dapat kasama yung negative. Yung iba kasi na-miss out yung negative dito. So, kasama siya. Okay? So usually ang ginagawa nila, ito yung ginagawa -3 and this is 1. Para 1, 1, 1 lang yung nasa output. But then again, it's supposed to be the product. So ibig sabihin, pwedeng lagay natin is 1.5. Okay, and -2, it's okay. Because 1.5 times -2 is -3 as well. Naintindihan po? Yes. So that is the diagonal canonical form, DCF. So, punta na tayo sa last lesson natin, guys, no? In this actual module. So this would be the last lesson, guys, no? So up until this would be the coverage of our exam. So, convert the given state model to transfer function. Okay. All right. Okay. By the way, guys, no, minsan pa iba-iba yung the way that they write the the state model. It differs no from one reference to another reference. But I think you can figure it out, no? Like this one, no? Sige. I will transform this no to the usual format na sanay tayo, guys. Okay? I will write this to the usual format na sanay tayo. Ang ibig sabihin ng dxt over dt, remember, the x here is the, yung x dito is a matrix. Matrix po yan kahit na ganyan yung pagkakasulat. Matrix yan. Okay? Or vector yan. Same goes with this, no? So yung x dito, state variable yan. Okay? So, matrix din to. So, this is matrix also. And kasi sabi ko nga, no, the way that they write the equation differs from one source to another source. Okay? Sige. So, let me write it to the usual way na sanay tayo. So, this is nothing but x1, x2 lang yan. Okay? Derivative kasi, ano, di ba? dx over dt. Time derivative po yun, ibig sabihin. Okay? Hmm. Tapos ito yung laman ng ating matrix, no? State matrix yan, 0, 1. And then we have -2, -3. Okay? And then multiplied by, again, yung x dyan, matrix po yan na x1, x2. Usual format na alam natin. Okay, plus. Okay, this is the output matrix, definitely. So this is 0, 1. Okay, and then this is what? This is the R. This is the R. Okay, guys. And then we have the Y. So the output is Y, right? Okay. And then we have the 1, 2 here, written as 1, 2. Okay, and then we have the X again. So again, the X is nothing but X1 and X2. State variables po yan. And then 0R. So feed-forward matrix is 0. Okay. Yan. So pangit tayo sulat ko pero anyway. Yan. Sige. Now, how to convert this one, no, to a transfer function. So meron tayong general formula, guys, no. We use that, no, kung walang canonical form na kamukha yung given natin. Right? But in this particular case, no, very obvious, this is in the what? This is in the, yeah, this given is in the controllable canonical form. So this is definitely in the controllable canonical form. And so this is in the CCF. Tama? Controllable canonical form siya. So, therefore, controllable canonical form, we can just simply write the corresponding ano guys, answer already. So, hence, so since CCF po siya, so yung output natin is Y, so you have Y of S. Okay, the input is R, so you have over R of S. Yan, so, equal siya guys ha. Okay. Alright. So, pagka ganyan guys, okay, pagka ganyan po, okay, no, so as we can see here, no, first, we can write the gain. So, sa gain sa CCF, this is the gain, right? Ito po yung gain natin sa CCF. Yan yung gain natin. So, this is definitely the gain. So, you can just write 1 here. Okay. Tapos, ano po? Yung sa output natin, okay? This one, guys, written nga lang pabaliktad, no? Pabaliktad, guys. Meaning to say na sinulat natin siya, we started with 'di ba? Kasi kapag galing sa transfer function, start tayo sa dulo pabaliktad. So balik lang natin. What do you mean, sir? So ibig sabihin this is nothing but 2s plus 1. It's nothing but 2s plus 1. Kasi pag sinulat mo siya pag ganyan, 'di ba? Kaya pag ganyan, 'di ba? So bali 1 tsaka 2 pag sinulat mo. Pero pag pabalik, this is 2s plus 1, no? So bali babasahin mo rin siya pag ganun, 2s plus 1. Or maybe you can just read it that way. Pero remember, sa dulo ka mag-uumpisa. So 1 tsaka 2. Okay? So, ayan, figure out nyo na lang, no? I think you can understand, no, kung paano siya nangyari. Basta to double check, no, once na masulat mo na siya, gawin mo na siya yung usual, di ba? Pag i-convert natin siya saan? Ano po? I-convert natin siya sa output equation. So, di ba, pabalik siya and we don't have any change the sign there. So, that's, no, pag nirite mo siya, dapat 1, 2, right? So, 1, 2 naman. So, it verifies na correct. Okay? Mm. For the denominator, guys, no, so we have -2, -3. So same lang din yung idea, guys, no? Pabalik lang din siya. Isusulat lang din natin siya pabalik. Okay? So we have start tayo sa -2. Kaya lang dito may change the sign. So this is nothing but 2. And then we have -3. So this is 3. Kaya lang increasing power to, no? So plus, ano siya? Plus 3s. Yan. Kaya lang, di ba, kung nare-recall nyo sa canonical form, guys, okay, yung first natin, okay, hindi siya kasama dun sa last row. So, yung first dito is s square. Okay, so that is s square 3s plus 2. So, again, no, so double check nyo lang, guys. Dito kayo mag-uumpisa, di ba, pag sinulat nyo, pabalik siya. So, that's -2, -3. -2, -3. Okay? And so, here's our answer. So, pag sinulat natin ng maayos, guys, so let us write this ng maayos. What do you mean maayos, sir? Hindi natin lalagay yung gain. So, we have 2s plus 1. Okay, so we have 2s plus 1. Yan. Upon, ano guys? upon S square, okay, plus 3S plus 2. Okay? Yan. So that is our answer, guys. That is our answer. Okay? Alright. Sir, pwede po ba yun? Di ba usually dapat yung leading coefficient ng numerator ay 1? Eh, ba't ito 2s plus 1? Pwede naman yun. Parang anong nangyari lang, instead of putting the 2 in the gain, kinere niya dun sa y. Okay? Pwede naman yan. Okay? No problem. So, we will arrive at the same answer. Okay? Sige po. So, this is still a controllable canonical form. Alright? O, sige. Okay? Sige, let's have another one, guys. So, this is another given po. So, pag tinignan natin maigi, guys, no? So, what form is this one? What form is this one? Okay. So, may number sa diagonal, okay? Pero dun sa, wala. 0, 0. So, therefore, this is what? This is nothing but the, guys? This is nothing but the diagonal canonical form. Okay, DCF naman siya. So, what will be the solution, guys? We will write the answer. Okay, so this is nothing but the, DCF. So, using DCF, yan. Definitely, this is in the DCF form, diagonal canonical form. So, using DCF, guys, paano nga ulit yun pag DCF, sir? So, kunin mo na kagad yung Y of S upon, okay, R of S. Matik na yun, guys. Alright? And then, next is, yung mga poles natin, that would be the denominators. So, di ba, -1, -2, so this is S plus 1, and this is S plus 2. Okay. Numerators, guys, ay product nung corresponding elements. Like this one. Product nito to this one. Okay? And product nito, guys, nung 3. Oops, sorry. Product nung 3 dito. Okay? So, -1 times 1. So, this is nothing but -1. Okay, plus. Yan, no? So, we have 3 times 1. So, this is nothing but 3. Okay, this is nothing but 3. Okay? Yun, ganun lang, guys. And then, of course, no? So, syempre, pag transfer function, okay, kailangan ibubuuin natin siya. You know what I mean, no? So, this would become what? -S minus 2, right? Cross multiply lang. -S minus 2. And this is 3s plus 3. So, 3s plus 3. Okay, upon, guys? Yung product ng dalawa, which is, what's the product of that? S square plus 3s plus 2. So, actually, guys, no? Tingnan nyo. Ito ay what? Di ba? 3s minus 2s, that is 2s. Okay, we have -2 plus 3, so plus 1. Okay, upon, guys? S square plus 3s plus 2. So, kita nyo, guys? It's the same, right? So, yun yung nakuha natin kanina. So, different state models, right? Pero same transfer function. Okay, no? So, nakuha din natin siya, no? Na-solve din natin using the diagonal canonical form. So, actually, diagonal canonical form is the fastest, right? This is the fastest, okay, way. Kasi nga, very obvious siya, no? Okay. Hindi naman fastest, no? Kumbaga, madaling ma-recognize. Okay? Kasi dito sa, sa controllable canonical form, kailangan dito, ang pinaka-critical dito yung 0, 1. So, pag hindi po to 0, 1, guys, okay, look at this, no? Pag hindi siya, I mean 0, 1. Pag hindi po siya 0 tas may value na gain, hindi po siya controllable canonical form. Usually ganun eh. Mamaya may example tayo na almost it looks like, no? It the prototype is no, parang talagang mukha siyang controllable canonical form, doon lang mag-iiba doon sa input matrix. Okay, doon lang mag-iiba sa input matrix. Kaya biglang hindi na natin pwede gamitin yung controllable canonical form. Okay? Sige. So let's have this one, guys. Ayan. So as you can see here, no, pag tinignan nyo, as if it was an observable canonical form, right? So medyo mukha siyang observable canonical form. However, hindi po siya observable canonical form. Why? Because, okay, no? Kung observable canonical form po ito, okay, kukunin mo lang yung niya eh, 'di ba? Transpose niya. So if you get this transpose, okay, no? Kasi mukha siyang no, maaaring tayo, magkaroon tayo ng idea if it is no, the observable canonical form. But if you will check, kukunin mo yung transpose nito, no? You will write it as 0, 1. Okay, that's good. And this is -2, -3. That's also good. So parang ito yung state matrix ng controllable canonical form, right? Okay, plus, okay, ang mangyayari dito guys, ang kukunin mo rito is yung ano no, tatayo tong 2, -5. So this would become 2, -5. Okay? And then this is the R. So definitely this one, this is not CCF. Right? Because 'di ba pag kinomay transpose no ng observable canonical form, you should go to the I mean pag kinomay transpose nung ina-expect mo na observable canonical form, dapat nang lalabas ay controllable canonical form. Eh 'di ba 2, -5, hindi siya 0, 1. So mali. Okay? So in other words, mali. So hindi siya pwedeng gamitan ng ano po, hindi siya pwedeng gamitan ng hindi siya observable canonical form, sorry. So we cannot treat it as observable canonical form. So paano gagawin, sir? How are we going to solve this one? So ito yung walang form, no? So kumbaga yung formless, no? So ito yung sasabi kong formless during the discussion ng on-site class natin. Alright, guys. So, paano po ang magiging solution nito, no? How can we write the corresponding state model, okay, from this one? So, kung hindi siya, guys, no? Kung hindi po siya standard form, okay? So, wala siyang mga standard canonical forms, we will use, no, the formula on how to get the transfer function. And what is that? So, the formula to get the transfer function, this is nothing but, okay, y of s. And usually, y kasi yung output. Okay. Kapag state matrix, yan, so y of s upon u of s. So actually, u of s yung gamit nila, no? So this is nothing but, ano po, C, okay, matrix C, the output matrix, into Si minus A inverse, okay, times B. And wait lang ha, yan. So there's a blotting, no, for, dun sa, ano, no, sa pen. So I'll just pause for a bit. Okay? So, yan, no? So, and I hope na okay na to. So, sige, no? So, ano nga uli yun, sir? So, this is, yan, y of s upon, okay, u of s. Yan, guys. So, this is nothing but c into si minus a inverse. Okay? B plus d. Yan, no? So, ito yung ano, no? Pinaka-general formula that we can use, guys, if you want to get, no, the transfer function, okay, from the state model. Okay, without the original forms. Sir, pwede po bang gamitin yan, no? Kung hindi ko na-recognize yung form. Kuya, diretso gamitin ko na yan and I'll be able to get the answer. Pwede. Okay? You'll get the same answer. However, guys, it's not advisable na diretsong gamitin yan, lalo na kung kasama naman siya sa mga canonical form. Dahil getting the inverse of a matrix sometimes is a little bit hard. Especially kung hindi na siya 2 by 2, kung 3 by 3 na. No? So, mahirap po. Okay? Mahirap po, no? But yeah, I will also teach you later a technique, guys, no? To be able to solve very easily a 3 by 3 matrix na inverse. Kaya lang, mahaba pa din yung process. So if it's one of the canonical forms, no? So you're wasting time. You're wasting time and effort kung kasama naman siya sa mga canonical forms. Pero don't worry guys, no, kunyari hindi mo na-recognize na ano siya, one of the three canonical forms that we have or four kasama yung Jordan. So that's okay. That's okay. Okay? That's okay. Right? You can use the formula and you'll get the same answer. You can use the formula and you'll be getting the same answer. All right? Okay. All right, sige. So, game, let us solve. All right. Let us solve. So what will be the solution? What will be the solution? So what will be the solution? So solve po natin, guys. Ready? Go. Let's go. All right. All right. Okay, guys, no? So, sir, ano po ba yan, no? So let's do it step by step, guys. So what do we mean by Si minus A? Remember, no? So let's name this one. So ito yung A natin, guys, no? Because this is your state matrix. So this is your A. This is nothing but the B. This is nothing but the C. So this is nothing but the C also. Okay? Sige, guys. So what is C of S? Unahin natin yung Si minus A. Anong sabihin ng Si minus A? So kung nare-recall nyo pa sa advanced math nyo, guys, so yung quantity Si, okay, Si, yan, minus A, Yan, no? So, paano siya ginagawa? SI means ano, no? Yung diagonals natin. Kasi ang I is the identity matrix, right? So, I is nothing but the identity matrix. So, saan ko ba lagay? Dito na lang siguro, guys. So, I is the identity matrix. So, pag identity matrix, that is 1, 0, 0, 1. Okay? For 2 by 2. So, for 3 by 3, kung 3 by 3 man if ever, so the 3 by 3 is nothing but, ano po, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? So, yan no, kung ano guys, kung 3 by 3. So, ibig sabihin, no, yung SI, okay, SI is yung diagonal natin mapupuno ng S. Okay, mapupuno ng S yung diagonal natin. So, that would be S and S. And minus A is meaning to say, ima-minus mo yung matrix A sa kanya. Like S minus 0, okay, that is nothing but S. S minus 3, this is nothing but S plus 3. So this is nothing but S plus 3. Okay? S plus 3. S plus 3. Okay? And then we have what? Okay. Kasi 'di ba diagonal ng ano, yung diagonal nung ating identity matrix ay 0 naman yung upper right element. So 0 minus negative 2, that is positive 2. Okay, this is positive 2. And then this is negative 1. Okay, so naintindihan po ba? Sir, hindi po masyado. Sige, I will write this very, very step by step. I will write this very, very step by step. No? For the sake na magets natin siya, ha? Sige, guys. Okay, first is I will write the SI. I will write the SI. So what is SI? So this is nothing but S0, 0, S. So that is the SI. Now, what is SI minus A? So SI minus A, di ba ano yung S natin? S0, yan 0, 0, S. Okay, minus A. So what is our A, guys? So our A is 0, negative 2, then 1, we have minus 3. Okay, minus 3. All right. So what will be the result of this one? So what would be SI minus A, guys? What would be the SI minus A? So SI minus A is nothing but S minus 0, S. 0 minus negative 2, positive 2. 0 minus 1, negative 1. S minus negative 3, S plus 3. Nakuha na, guys? Okay, very good. So that is ano, SI minus A. Again, you don't need to do this step by step. No? So if you can think directly, ano ba yung SI minus A, pwede na. Okay? Okay na. Diretso na yun. No? Pwede nyo na diretso yun, guys. Oops, sorry. Lumipat agad. Yan, no? Yan, no? So, yan. May apologies, guys, no? Kung kailan towards the end of the session, no? The pen is malfunctioning. Okay, guys. So, now, paano to get the inverse, no? Actually, getting the inverse of 2 by 2 is a little bit easy, right? So, madali lang kunin ang inverse ng 2 by 2 matrix. So, paano ba kunin ang inverse ng 2 by 2 matrix, no? So, SI minus A, okay, inverse. Yan, no? So, how to get the inverse, no, of a 2 by 2 matrix? So, the denominator is, of course, nothing but the determinant, no? So, the denominator is nothing but the determinant. So, let's just get the determinant. What's that? So, this is, ano, we have S square plus 3S. Yan. Bali determinant nung ano no, SI minus A. So, di ba may SI minus A matrix ka? So, that is S square plus 3S. Okay, minus 2, but you change the sign, so this will become plus 2. This will become plus 2. Okay. Ngayon guys, no? So, to get its inverse, yung denominator natin, I mean, the numerator guys is another matrix po. So this is another matrix. So paano ba kunin no yung inverse guys, no? How to get the inverse of a 2 by 2 matrix? So madali lang guys. Pagpapalitin nyo lang yung dalawang diagonals. So yung S saka S plus 3. So this is nothing but S plus 3 and this is S. Okay? Ngayon, yung diagonal na cross diagonal naman, you just change the sign naman. So this is negative 2 and ano, positive 1. Nakuha po. So, ganun ha. Again ha. For the main diagonal, pagpapalitin nyo lang. So, S plus 3 and S. Okay. And then the alternate diagonal or the cross diagonal niya, you just change the sign. Okay? Yan. Yan. Basically, that's the inverse. This is the inverse of SI minus A. This is the inverse of SI minus A already. Now guys, next operation no, do sa formula is multiply natin sa B. So we have SI minus A, okay, inverse multiplied by matrix B. Yeah, no? So as I mentioned guys, no, during the introduction of this lesson, I've told you guys na you should, you should be very good at the linear algebra, no, if we are dealing with the state space. Kaya medyo mahirap siya guys, no? Kaya nga, majority of our lesson would be focused on classical control theory. Okay? So ito, copy lang natin, no? So that is S plus 3, okay, minus 2, then we have 1, and then we have S. Saan natin siya i-multiply guys? No, yung matrix B, yung patayo, which is 1, 0. Okay? So, we will multiply this to 1, 0. So, paano uli mag-multiply ng matrix, sir? Okay, no? So, bali parang ano siya, no? Dot product. So, mangyayari is S plus 3 and negative 2. Mumultiply nyo kay 1, 0. So, ano magiging result nun, guys? So, magiging result nun is, S plus 3 times 1, negative 2 times 0. So, this is nothing but S plus 3. Tapos yung next row naman, which is 1s, mumultiply nyo din kay 1, 0. So 1 times 1, this is nothing but 1. And s times 0, this is nothing but 0. So pangayan guys. So kaya upon, guys, we have s square plus 3s plus 2. So yan siya. Okay? And finally guys, no, you just need to multiply this whole thing by c. You just need to multiply the whole thing by c. And multiply natin the whole thing by c. So ano yung c natin? Okay? So yung, yan, no? So bali, gagawin na nating resto ng operation. So bali, we have C. Okay, multiply nung result natin kanina, no? Which is the S minus A. Okay, inverse multiplied by B. So basically, ang mangyayari dyan is yung matrix na nakuha natin kanina, which is this one. No? So diba, this is S plus 3 and 1. S plus 3 and 1. And tapos yung denominator, which is S square plus 3S plus 1. Okay, plus 2 pala rather. I-multiply kay, guys, what is the matrix C? So the matrix C in this particular case is 2 minus 5. 2 and negative 5. Okay. So parang dot product lang din uli guys, no? So what will happen? Okay, bali yung 2, multiply nyo kay S plus 3. So that is 2S plus 6. That is 2S plus 6. Okay? And then yung negative 5, i-multiply nyo kay, guys? I-multiply nyo kay 1. So that is negative 5. Okay, upon, we have S square plus 3S plus 2. Okay? So, basically, since your D is 0, right? Kasi di ba the feed-forward matrix is 0. So, madalas wala na to, no? Yan, pero meron siya kung may value yung feed-forward matrix natin. Pero in this case, wala, no? So, 0 siya. So, basically, yun yung answer. So, hence, yan, no? So, what will be our answer, guys? So, our answer would be ating Y of S, okay, upon, okay, hindi U of S dito, no? Kasi R yung ating input. So, R of S ang gagamitin. So, equal po siya saan, guys? Equal siya sa 2S plus 6 minus 5. So, that is nothing but 2S plus 1. This is nothing but 2S plus 1 upon S square plus 3S plus 2. Okay? Alright. So, the same lang no kanina, right? No, ibig sabihin tama yung answer natin, no? Kasi yung kanina, di ba, ito? So, kanina, ito din. So, actually, pare-pares tong tatlo na to, no? So, yung mga given natin, pare-pares ang transfer function niya. To show you guys, no, that the state model is not unique, but the transfer function is. Okay, the transfer function is. So, the first one, di ba, we solve it using the controllable canonical form. The second one, we solve it using the diagonal canonical form. And the third one is just the normal, yung walang standard form, no? Okay. So now, we are come to the last example, guys. So this one is a little bit longer. Mahaba siya i-solve, no? Because this is a 3 by 3 matrix. Okay, and look at this, no? Tingnan nyo maigi, guys. Mukha siyang controllable canonical form, right? Look at the state matrix. 0, 1, 0, 0, 0, 1. That's a bunch of negatives, no? Sa last row. Output matrix 100. That is also one possibility that is an actually controllable canonical form. However, look at the matrix B. Look at your matrix B. 'Di ba? Again, this is matrix A. This is matrix A, guys. Ayan, masyadong magkadikit. But this is matrix A. Look at your matrix B. And this is matrix C. So, hindi na sinulat yung matrix D kasi 0 siya. So, yan, during the class, di ba, I've told you, pwede nyo naman isulat, pwedeng hindi, pero hindi niya sinulat, no? Meaning to say, zero kasi yun, no? Kaya hindi niya sinulat. So, matrix D is zero. So, look at your matrix B, guys. Dapat ang controllable canonical form ay 0, 0, and nasa dulo yung gain. But in this case, 10, 0, 0. So it means, guys, na hindi siya CCF. Hindi siya controllable canonical form. So paano yun, sir, pagka ganun? So we have no choice, no, but then to use the standard formula to get the uh, transfer function from the state model. No, yung ito, no, yung ginamit natin in the previous problem, gagamitin natin siya dito. Okay? Yan. So medyo mahaba, no? So please bear with me. Yeah, let's go. Let us solve this problem step by step. We have the solution. We have the solution. Okay, guys. First is we need to, guys? We need to get the SI minus A. So we will get the SI minus A, guys. Yan, no? So rectine ko na yung SI minus A. So, dun sa previous problem, dinahandaan ko po ito. So, hopefully na alam nyo na siya gawin, no? Dahan-dahan also. Pwede naman. I mean, alam nyo siya na gawin na dahan-dahan, pero hindi ko na dahan-dahan din dito, guys, ha? Okay? So, what is SI minus A po? What is SI minus A? Yan, SI minus A. So, SI minus A, so this is S. Okay, this is -1. This is 0. Okay, this is 0. Okay, this is S. Okay, and this is -1. Okay, this is +1. This is +2. And then we have the S plus 3. Then we have the S plus 3. We have the S plus 3. Okay. Now, to get its inverse, yan. Ito yung medyo mahaba, guys. Okay? So I'll be teaching you a technique, no, to get the inverse of this matrix. So probably you have the idea already to get the inverse of the matrix, no? So probably na-lesson siya sa advanced math, most likely, I think. No? So na-lesson niyo yung pagkuha ng inverse ng matrix, guys. Pero I think yung pagkuha ng inverse ng matrix doon, okay, may letter. May letter ba o wala? I'm not sure. May variable or wala. So kaya to mahirap, guys, no? Kasi may variable, no? So kung wala kasi, you can directly use your calculator. Okay, no? So let me teach you a methodology on how to do it. Okay? Okay, what's the first step, guys? So the first step, guys, actually is to transpose the matrix. We will write the matrix, no, na nakatranspose siya. Okay? Yeah, no? So to get the inverse, no? So ang gagawin natin, we have the S, we have the 0, and then we have the 1. Okay po? Okay. Next is, we have -1, and then we have the S, and then we have the 2. Okay? So, kinukuha natin yung inverse niya. So far, ganyan ang ginagawa natin. And then we have the 0, -1, S plus 3. So 0, -1, and S plus 3. Okay. Now, we will append this matrix. When I say append, we will add, no? We will augment, no? So basically, ang gagawin natin is, uulit natin yung first two rows. So this is yung addition ko, no? S, -1, and 0. And then we have 0, we have the S, and we have the -1. Gets? Ulitin niyo yung first two columns. Rows ata na sabi ko kanina, sorry. So ulitin niyo yung first two columns, guys. And then, you will repeat the first two rows sa baba. No? Meaning, this is S0, 1, S0. And then we have -1. Okay, S2, -1, S. Malinaw, guys? Yes. Now po, lalagyan niyo siya ng hati, no? So, pag ganyan. Okay? So, lagyan niyo ng hati na pag ganyan, guys. So, kumbaga parang i-border niyo yung parang niya, 4x4 section niya. Okay. Tapos, guys, you'll just perform. Okay, no? So, bali kasi ito na eh. We can write now the inverse, no? Directly from here. So, what is the inverse, guys? SI, okay, minus A. Yan, no? Inverse. So, we can write it directly here, guys, no? So, medyo i-adjust ko lang. Kasi kasama nga pala yung buong matrix, no? Okay, guys. Look at this, ha? Tingnan niyo po maigi po. So, ito yung matrix natin. Tingnan niyo po maigi, ha? Yung gagawin natin. Okay. Cross, lang siya, no? Yung parang pag-multiply ng determinant, guys. So, bali ito. Okay. This one. Multiply niyo po dito. Pag ganyan. Okay, tas just the usual, no? Pag pababa is positive, pag pataas is change the sign. So, bali, S times S plus 3. So, this is nothing but, okay, no? So, I think mas mababa pa to. Buburin ko muna to. So, this is nothing but, ano guys, S square plus 3S. So, this is S square plus 3S. Okay? And then yung pataas, that is negative 2, but change the sign. So, plus 2. Okay. Next naman, guys, yung pababa naman. So, pag ganyan, ha? Pag ganun. Okay, tapos pag ganun. Okay? Ayan, no? So, tuloy-tuloy lang, guys, no? So, bali, negative 1 times 1, that is negative 1. And then 0 times S plus 3, so this is nothing but negative 1. Okay? And then yung pababa, guys, definitely, ito po. So, bali, 0 times 2, tapos S tsaka 1. Okay, so 0 times 2, that is 0. Tapos S times 1, that is S, but change the sign. So, we have negative S. Okay po. Alright. Next. Okay, next naman is yung gitna naman. So yung gitna, okay, paano po yung gitna guys, no? So ganito lang din. Okay, so para hindi kayo, usually ang kagandahan nito, usually wala ka ng parang ano, pinaka-anchor na row. Next row, ito na rin. Ganyan lang. So tuloy-tuloy lang guys. Parang ano, kung ano yung mga elements lang, yun mismo yung i-multiply nyo. So kumbaga, 2 times 0, tsaka S plus 3 times negative 1. So this is nothing but negative S minus 3. That's it. Negative S minus 3. Hmm. So sana nag-guess na yung pattern ha. Tuloy-tuloy ko na ha. Okay, we have S squared plus 3S. So next one. And the other one is negative 1 minus 2S. Negative 1 minus 2S. Okay? All right. And then for the last column, okay, negative times negative, that's positive. So this is positive 1, 0, negative S. So this is S. And then we have S squared minus 1, that is S squared. Okay? Yan. Yan. So naintindihan guys? So hopefully, no? So hopefully you understand. Okay? So, bale, yeah. Ito rin, no? Multiply rin siyang ganyan. Okay, now we will get the determinant. So, paano po yung determinant? So, the determinant is you will, ano, no? You will box this one. Bakit, no? Kasi itong S, imumultiply nyo dito sa first element. Okay, this second one, 0. Imumultiply nyo sa second element dito. And then the 1 here will be multiplied here. Okay? O, sige ha. So, multiply natin. What is S times S squared plus 3S plus 2? So, this is nothing but S cubed plus 3S squared. Okay, 3S squared. Okay, plus 2S. Plus 2S, right? Plus 2S. Okay? 0 times negative S minus 3, that is 0. 1 times 1, that would be plus 1. Okay, yan yung determinant actually. Ang galing, no? O, kasi mahirap kunin yung determinant, di ba? Kapag ka 3 by 3 matrix, haba niyan, di ba? But getting the determinant, guys, is very easy using this technique. Okay? All right. So, yan na yun. That's it. That's the inverse of SI minus A. So, let's continue, guys, sa next step. Ano po ulit yung next step, sir? So, the next step is multiply this whole thing by the B. Yan. Kasi kung nare-recall nyo, guys, no, ano nga ulit yung formula na sinusunod natin? So, yung sinusunod nating formula, this is nothing but, okay, y of s. Yan, no? So, yan, yung sinusunod nating formula, no? So, y of s over u of s. So, this is given as C times SI minus A inverse times B. So, unahin natin yung multiplication by B, guys, no? Unahin natin yung multiplication by B. Okay. No, so, in this particular case, pwede naman din unahin yung C. I think you'll get the same answer, pero nakasanayan ko ng unahin yung B. So, we will do that. Okay, we will do that. So, paano po yun? Okay. So, we have, ano guys, we have the quantity SI minus A inverse multiplied by B. Okay? So, yung result kanina, so, equals to ha, dito ko na nalagay. So, yung result kanina, so, let me rewrite the result, no? So, that is S squared plus 3S plus 2 minus 1 minus S. Then we have minus S minus 3. We have S squared plus 3S. We have negative 1 minus 2S. And then we have 1. We have S. We have S squared. So, i-multiply natin siya guys dun sa patayo natin na 10, 0, 0. Okay, so multiply natin siya dito kay, ano guys, 10, 0, 0. Because this is the matrix B. Upon, okay, no? So yung denominator natin remain the same. Which is the s square plus 3, s cube plus 3s square plus 2s plus 1. Okay? Oh. Ngayon, pag na-multiply ka, parang dot product, guys, di ba? Kung nare-recall nyo. Kumbaga, s square plus 3s plus 2 times 10, negative s minus 3 times 0, and 1 times 0. So that's the first element of the answer. So this is the first element of the answer. So that is 10 into, ano guys, s square plus 3s plus 2. Okay? Second element. What is second element? Negative 1 times 10. So that's negative 10. Okay? S square plus 3s times 0, s times 0. So you just obtain that one. And then negative s times 10. So that's negative 10s. Okay? Tapos negative 1 minus 2s times 0 plus s square times 0. So that's 0 also. So bali ito na lang may iwan guys. Okay? So don't be confused ha. Kumbaga, yung mga ibang result kasi plus 0, plus 0. Okay? Plus 0, plus 0, plus 0, plus 0. So we don't write it anymore. No? So di na po natin sila sinusulat po. Okay? Yan. So, bali ito na lang yung naiwan kasi puro plus 0 naman. And then, the determinant, yan, is still the same. So, that is nothing but, s cube plus 3s square, okay, plus 2s plus 1. Okay? So, let me just copy this, guys, because I think we need to insert another slide. Yan. So, para madala natin sa next slide. Okay. So, continuation ng ating solution, guys. Continuation ng ating solution. So, this is the, this is the result earlier. Yan, no? So, ito na po yung, guys. Yan, this is nothing but ito na po yung ating, guys, SI minus A inverse times B. Yan na po yun. And finally, guys, no, ano pong kailangan natin? So, we need, okay, multiply this whole thing, guys, by C. Multiply this by C. Okay, matrix C natin. Okay, matrix D is 0, as you can see here. So, hindi natin siya kailangan i-add. Okay? So, yan. So, bali, pag multiply natin to by C, so, kompleto na, di ba? SI minus A inverse times B. Okay? So, what is matrix C, guys? So, saan natin i-multiply ito? Okay. Mas medyo usog ko pa. Okay. Saan natin i-multiply, guys? So, nakamultiply siya doon sa matrix C, which is 1, 0, 0. Okay? Sige. So, what will be the result, guys? So, bali 1 times this whole thing po. So, that is 10 into, guys? S square plus 3s plus 2. Okay? Tapos, 0 times negative 10. So, that is 0. Okay, 0 times negative 10s, that is 0. Pero kung hindi 0 yung mga yun, you need to add, no? Kumbaga, ang mangyari kasi plus 0 plus 0. Right? Yan, 0 na kasi yung result ng product po, no? Kumbaga, product nito tsaka product niyan 0. Kung hindi siya 0, i-add nyo siya doon sa value na yan. And this is, copy lang natin, s cube plus 3s square plus 2s plus 1. So finally, guys, no, we can now get the transfer function. Ingat sa mga letter, the letters that you should use should be correct. So that is y of s upon u of s. Yan. Because in this particular case, the output is y and the input is u. So equal to, guys, saan? Okay, this is equal to, okay, let me write the whole trans function now. So this is nothing but s cube plus 3s square plus 2s plus 1 upon, yan. So no need to factor in the gain, okay na yan. So that is s square plus 3s plus 2. Okay? And this is our answer. Yan, that is our answer. Okay. Yan, no? So, yan, medyo mahaba, right? Okay, no? So, again, guys, no? So, this is our answer. All right. Yes, yes, sir. So actually guys, no, that's the end of our discussion. No? So thank you everyone. And guys, no, so yeah, if you have some question, guys, no, don't hesitate to ask me. So you can reach me to our usual means of communication. So God bless everyone. Thank you for watching this video and bye guys. Bye.